This lesson topic covers what we call the measures of dispersion. Now, up until now, we've had a look at the measures of central tendency. That is, the numbers that sort of push towards an average. Those were the mean, the mode, and the median. So a measure of centralness. This topic has a look at our measures of how things spread out and the patterns that can occur. So we have a look at a couple of things here. Look at these two sets of data. There they go, 3, 4, 5, 6 and 7, and 0, 1, 5, 9 and 8. Now if you put these into the calculator, you'll find that both of these have the same mean. This has got a mean of 5, and so is this one. Now, the important thing though is to look at them and say there's quite a lot of difference actually between these two. If you have a careful look at it, then you'll see that the sets of scores are different, and it says the first set of scores are more closely grouped around the mean. There it is there. And in this case, they're far more spread out or scattered from the mean. So it says, as well as having a central value for a set of scores, it's also good to have a look at the measure of scatter, or how far apart they are. So these things are called measures of dispersion. And there's a number of ways we can do that. And in this topic, we're going to have a look at two of those ways. And the first one is the range, which is one that is most common and most people would know about when they look at a topic like this. And the range is very simply just the highest score and the lowest score subtracted, or the difference between the two. So let's have a look at doing some pretty straightforward calculations. The important thing to notice is that you must always make sure that you've got your numbers either in order, or make sure that you do take the highest score and the lowest score, and you don't miss out on those. So there's our range in this case of 4. And as you can see, for all of these ones, they're very straightforward. The answer here is highest of 10. Take away our 0, so that gives us our range. And the last one is a score of 70, and take away a 3 gives us a score of 67. Now, it's very interesting that this number here has really affected the range. These are all, they've all got the same numbers of scores, but notice that some of them are fairly close to each other, and then they slowly get further and further away. And so the range helps us to look and compare these. The other thing that you need to notice is the range is not the actual number 7 minus 3. If you're asked to write down the range, you actually write down a number. So you do the solution of the subtraction, not just write down, oh, the range is from 3 to 70. You actually have to give a number for that. Now, there's a special kind of range that we want to have a look at called the interquartile range. And I think you can see from here the word quarter seems to come into it, interquartile range. And that's actually true. It says we're familiar with the concept of the median, which divides the data into two groups, and it says with an equal number of scores in each of the halves. So there's the median, cuts the scores in half when they're in order. And what happens then is we can actually take each half and divide it again so that we get the data into 4 equal parts, or in this case quarters. So that's where the word quarter comes from. And it says these scores are called quartiles. Now the quartiles are the scores that actually divide the numbers into 4. Just like the median is a number that separates numbers in the data into 2 parts, quartiles are the numbers that divide it into 4, which means there are only 3 quartiles, and the middle one, Q2, quartile 2, actually is the median. So these link together. So Q2 is the median. Now, I'll show you this by example. It's quite easy to see, but there's the definition that you must know and that is that the interquartile range is the third quartile minus the first quartile. And you'll get an idea of this as you look at some numbers. So it says the difference between what we call the upper quartile and the lower quartile. Remember that the second quartile is the middle quartile, which is the median. There it is there. So let's have a look now at some examples to see how this works. I'll just move to the next set of diagrams. Now, in this one, I've got some answers for you, but let's have a look at the first one. Here's our data, and you'll notice that we've got to work out the interquartile range, and we've got a set of data that's in order. Very important to make sure that each time you do this, the numbers are in ascending order. So let's work through the notes, and then we'll do B and C without the notes and come to our conclusions. So write down the numbers in numerical order. This is a very important part. You can find the median by finding its position, which is n plus 1 over 2. And in this case, you've got 1, 2, 3, 4, 5, 6, 7 scores. 7 plus 1 is 8. 8 divided by 2 is 4. So the fourth score is given in there. That's our median score, or our median, which is also given the number Q2, or the second quartile. All right, so now if you have a look at what we've got here, we've got two more parts that have been created, the numbers that are below and the numbers that are above. And I think it's quite obvious when you look at this that the number here and the number here break up what was left over into equal parts again. So this would be our first quartile or lower quartile, and this one would be our upper quartile or our third quartile. So it says here the lower parts contain the scores 2, 2 and 3. There they are there. And it says that the lower quartile is the score which divides this set into two parts. There it is there, with the same number in each. So in a way it's like the median of that little part there and the median of that little part there. So that's how we work out our quartiles, 1, 2 and 3. So there it is there, 2 and 6 are our quartiles. And then we can work out our interquartile range by taking our third quartile, that's this one, which was 6, and subtracting from it our first quartile, which is 2, and that gives us our interquartile range of 4. Now you'll notice that the full range is 7 take away 2, which is 5, so the interquartile range, as you would usually expect, would be less than that. And there's a good reason why we work this out, as I'll show you shortly. Let's have a quick look now at these examples here. So, carefully counting them, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 scores. So we say therefore that the second quartile, that's the median, is in position n plus 1 over 2. So we've got, what was it again? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 plus 1 over 2, that's 10 over 2, which is 5. It's in position 5. So we can count across 1, 2, 3, 4, 5. There it is there. And there's our second quartile, or our median. Now, what we're left with is this group here and this group here. So if you look at it, I'll just change the colour here so we've got a bit of variety. That would have to be, and remember there's an even number there, if we worked out the average of this, that would be our first quartile, which would be our average, which is equal to 2, and our third quartile, so I'll write this in as our first quartile. Our third quartile is actually a number which is averaging 5 and 6 together. So 6 and 5 is 11, so half of 11 is 5.5. So that would be our third quartile. Alright, so that means therefore that the interquartile range, which we'll work out down here, therefore the interquartile range, I'll just use the word IQR for that, interquartile range. So I'll just make sure that we understand that. That's what we mean. Would be equal to our third quartile, 5.5, take away our first quartile, which is 2, and that gives us an interquartile range of 3.5. Alright, so that's how we do it. So it's obvious that you can actually have a number that has been created. In this case it has, it's 3.5, rather than actually being, or rather the third quartile is one that was created by averaging, which is pretty typical. Alright, now the next thing we need to look at is to see what this last one is. So we'll count it through. I'll change back to a blue colour here so we can just see the difference between the whole lot of them. We calculate 1, 2, 3, 4, 5, 6, 7, 8. So n plus 1 over 2 is equal to 8 plus 1 over 2, which is 9 over 2, 4.5. So the number that's in position 4.5 is what we're looking for quartile number 2, or the median. 1, 2, 3, 4.5. There it is in there. So there's our quartile 2. So quartile 2 would be equal to 3 plus 4, which is 3.5. 3 plus 4 over 2, that is. So there's quartile number 2 equal to 3.5. And all that has done now is neatly broken this up. Now, the thing that you've got to remember here is that because this number sits right in here, then all 4 numbers now are part of the lower quartile. So that's a very, very important point to watch. Notice here that that's the middle, so we've got to find, I'm sorry, 5 is in the middle, so we've got to find that one, and that one is our lower and upper quartile. This one is in the middle, so we've got to average them out, and in this case too, this is in the middle, so we'll find that average Q1 is equal to 2. Excuse me, that's our first quartile, and there's 5 and 6, so that's 5.5. That is our upper quartile Q3. So therefore the interquartile range is equal to Q3 minus Q1, and that would be 5.5 minus 2 as well. Alright, so in that case too, we have an interquartile range of 3.5. So I think the main thing to remember is to know how to do the median, and then be able to separate the two scores into the whole scores into 2 equal parts, and be able to find the medians of those, Q1, Q2 and Q3 altogether. Now, just one last thing on this page is to make sure you can see a few very, very important points. So I'm going to highlight some of these, and that is that 25% of the scores are less than Q1. That's the lower quartile. That means that 75% are greater than it. 50% are less than Q2. 50% are greater than it. And that's the median. And the upper quartile, 75% of the scores are left and 25% are greater than it. Now, you might use that sort of terminology when you come to discussing the interquartile ranges. So, or in any case, you'd be able to look at the proportions of numbers in different parts of the scores. So that's very important, having these quarters and halves and so on. So the interquartile range only has 50% of the scores, remember, because you're knocking off 25% at either end. Now, the other couple of things is that the interquartile range indicates the spread of scores from the median. So the range looks at the top score and the bottom score, but the actual interquartile range looks at how far things are spread from the median. And it says the greater the value of the interquartile range, the further the spread is of the scores from the median. And if you've got a relatively smaller value for the interquartile range, then it's more closely clustered around the median. So it gives an idea of spread. And then finally on this page, the interquartile range is very important because it is not affected by what we call atypical extreme scores. Now you might remember a name for this, and they are called outliers. And sometimes you don't want to include outliers in your range calculations. Now I'm just going to go back very quickly and remember the first example that we did, and I'll just get this here. And if we go back, I can, to here, there you go, look at that one there. That is an outlier. And that's why we've got to be very, very careful of maybe not using those in our calculations because they influence them unfairly. All right, in the last quick bit of this section, we're going to have a look at estimating lower and upper quartiles from an ogive. Okay, so let me just get a highlighter for that rather than, there we go, from an ogive. I'll move that into the middle a bit better. There we go. All right, so it says, hence find the interquartile range from this one. So how do we do this? Well, look, if you have a quick look at it, there are 120 scores. So that means that 60 down here must be our median score. 30 here must be our lower quartile because 30 is 1/4 of the way up. Our upper quartile must be 90. So the idea is to find the interquartile range, go for the lower quartile by going across to the ogive, which is that line joining the cumulative frequency bars, down to here, which gives us a 15. Going across from 90 down to the line and right down to the mark gives us a score of 25, and therefore we can say that the interquartile range is equal to 25 take away 15, which equals 10. So let's have a look at some of the important points out of here. It says locate the point 1/4 of the way up, which we did, that's Q1. Draw a horizontal line across to the polygon, and then it says drop a vertical line down to read off the lower quartile. And you do the same 3/4 of the way up, horizontal line, and then a vertical line down to the axis to read the upper quartile, and then we do our calculation for the interquartile range. So that's pretty straightforward. As long as you're given that sort of graph, it would be very time consuming to draw it, but it can be done, and it is quite a good way to be able to quickly read off the information that you need. Right, now the other thing we need to look at then is a situation where you're given a frequency distribution table, and it says to find the interquartile range of these marks. So let's have a quick look at it. We add our cumulative frequency column, which I've done for you. So there it is, 5, 5 and 9 is 14, 14 and 12 is 26, and so on. So there are 40 scores altogether. And then the next thing you would do is, if you needed to, you would draw your graph, your cumulative frequency histogram, and then join the lines up. Notice they're joined to the corners of the boxes, the top right hand corners join up. That would be your ogive. And from here you just find, just put that into position again, you find that there are 40 scores, so 10 would be 1/4 of the way up, 20 halfway up, 30 is the upper quartile, so there are your 3 quartiles, and go straight to the line and down to your numbers. So the first quartile is 5, the third quartile is 7, and when I subtract these, I get my interquartile range. So you can see from this type of histogram and ogive, it's a very easy thing to calculate. All right, now just moving this back a little bit again. There we go. Last example. Let's have a look. In the term test, the results of Kelly's class had a median of 65. That's for Kelly. And an interquartile range of 20. That's Kelly's class. So we'll put K for Kelly here. Sean's class, the median was 65. So it's exactly the same median. The interquartile range, however, is different. It's a range of 12. And it says, from the information given, what conclusions could be made about the results of the two classes? Well, conclusion 1 is that they have the same average or mean. But they have very different ranges. So in this particular case, we could see that the interquartile range is 20. And so you would say that for Sean, the class is, the range is much smaller. And so Sean's class is, and we'll put it here, Sean's class they are more closely clustered around the median. Remember that the interquartile range looks at the spread from the median. Very, very important that. So they're more clustered around the median than Kelly's class. I'll put here than Kelly's class. All right, so hers is much more spread out. So that's really all you can conclude from that, but it's a very, very important conclusion.